There are many ways to solve a system of equations like this one here. We've got x minus 2y plus 3z equals 9, 2x plus y plus z equals 3, negative 3x plus 4y minus 2z equals negative 16, and we're going to use matrices and row operations in order to solve this one. So the first thing we're going to do is write the augmented matrix associated with this system of equations. So we're going to write the matrix that goes with the coefficients, so the top equation becomes the top row. 1, negative 2, 3, and then 9. And then the next row is the coefficients 2, 1, 1, 3. And the third row is negative 3, 4, negative 2, and negative 16. I'll put the bar in to show the equal sign and draw, if it lets me, draw the last, come on, part of the matrix. Okay, now our goal is to get zeros in especially these lower numbers here. So the first place I would like to get a 0 is right here. And it's very hard to follow your work when you're doing these problems, so to keep track of that as best you can without having to scrap the problem and start all over again, I'm going to write next to each step where I got the row. So in order to get a 0 in that row, it would be fabulous if this number up here were actually a negative 2, because then we could add the rows together and get a 0. So I'm going to change, when I rewrite my matrix, I'm really going to change only row 2. So I'm going to keep row 1 as 1, negative 2, 3, and 9. I'm going to redraw that line. I'm going to keep row 3 the same. So negative 3, 4, negative 2, and negative 16. I'm just going to change row 2, and I'm going to tell myself what I'm doing to change row 2. So to change row 2, I'm going to multiply negative 2 by row 1 and add that to row 2. Okay, now I kind of like to record that work up there, so what I'm going to write is, let me erase, if I can do that well, this circle right here. Okay, and what I'd like to record up there, but maybe in a different color, like red, is what negative 2 times row 1 is. So negative 2 times row 1 is actually negative 2. Negative 2 times negative 2 is positive 4. Negative 2 times positive 3 is negative 6. And negative 2 times 9 is negative 18. Because I will forget. Let me go back to my green pen. I think that's the one I was using. All right, and now let's add those together. So negative 2 plus 2 is 0. Negative 4 plus 1 is 5. Negative 6 plus 1 is negative 5. And negative 18 plus 3 is negative 15. Okay, now I'm very happy. I have my 0 in row 2. Now, one thing that I'd like to do to keep my numbers as small as possible is notice if there's any common factors, because you can always divide or multiply any row by the same number. So let's take that row number 2. I notice that every number here, 5, negative 5, and negative 15, is all divisible by 5. So the next thing I'd like to do is I'd like to take row 2 and divide it by 5. So I'm not changing row 1 or row 3 again, so I'm going to write 1, negative 2, 3, and 9. And in the bottom, negative 3, 4, negative 2, and negative 16. And then I'm going to do what I said I was going to do, divide row 2 by 5. So 0, 1, negative 1, and negative 3. Okay, off to find some more zeros. So let's see, let's get a 0 in this spot now. Okay, so to get a 0 in that spot, I think the easiest thing to do is again use row number 1, but maybe multiply row number 1 by a positive 3, so this guy up here becomes a 3. So let me go back to the green pen and say what we're going to do. We're going to multiply row 1 by 3 and add it to row 3. Okay, let's write what that becomes. So that's going to give us, row 1 won't change, 1, -2, 3, and 9. Row 2 won't change this time, so 0, 1, -1, and -3. And to get that 0 in row 3, when we multiply -1 by row 1, let's write what those are. 1 times 3 is 3. -2 times 3 is -6. 3 times 3 is 9. And 9 times 3 is 27. That doesn't look like a 7. That's a little better. All right. Okay, let's go back to what these are going to be equal to. So 3 plus 0 is, oh, I'm sorry, what am I doing? 3 plus -3 is 0. -6 plus 4 is -2. 9 plus -2 is 7. And 27 minus 16 is 11. Okay, I'm loving it. 2 zeros in each of those spots. All right, so let's keep finding zeros. The next place I'd like to find a 0 is right here. Okay, so to find a 0 in row 3 in that spot right there, it looks like it would be easiest if we just did row 1. Oh, I'm being crazy. Sorry. I don't want to do row 1 because actually if I multiply row 1 by anything and add it to row 3, I'm going to lose in this spot, added to this spot, I'm going to lose the 0 I just found. That would be bad. So let me get all that writing off of there. So let's not use row 1. You know what? Let's use, if we did 0 plus 0, that wouldn't change anything. So let's do row 2 times 2. And then added that to row 3. All right, and that is going to get recorded in row 3. So I'll keep row 1 the same, 1, -2, 3, and 9. I'll keep row 2 the same, 0, 1, -1, and -3. Row 3 is the only row that's going to change, so let's write what we're doing to row 2 up here. 2 times row 2, 2 times 0 is 0. 2 times 1 is 2. 2 times -1 is -2, and 2 times -3 is -6. So when we add those red entries to our row 3, here's what we're going to get. 0 plus 0 is 0. Yay, our 0 didn't go away. Positive 2 plus -2 is 0. -2 and 7 is 5. And -6 and 11 is 5. Oh my gosh, I think we're almost to the first answer. So what do we have here? Let's take, I noticed that 5 and 5 are both divisible by 5. So let's take row 3 and divide it by 5. So that gives us the matrix. You know what? I'm going to go to the next page. So let's see. 1, -2, 3, and 9. 0, 1, -1, and -3. So if we go to the new page, okay. So I had 1, -2, 3, and 9. I had 0, 1, -1, and -3. And dividing row 3 by 5 gives me 0, 0, 1, and 1. Okay, once I get all zeros in these lower corners right here, so let me kind of make these brighter. So once I get zeros here, here, come on, it doesn't want to write, and here, then, there we go. Then I have what we call row echelon form. And row echelon form will allow us to use back substitution to figure out what our x, y, and z are. So this row 3, remember these are all of our coefficients. So if I write this out the long way, this is 0x plus 0y plus 1z equals 1. But I think we would rather just write that as z equals 1. So if you have something in row echelon form, you know that you have the z value right here. And now we can use back substituting to figure out what the other values are. So this row 2 is actually 0x plus 1y minus 1z equals -3. Or, in other words, let's see, plugging in z equals 1, we get y minus 1 equals -3, which means I've got z equals 1, and it looks like y equals -2. And then last, we've got 1x minus 2y plus 3z equals 9. And plugging in our values, we're going to have, let's see, we don't know x. 2 times y is 2 times -2, so -4. Whoops, that's going to be a +4, sorry. 2, okay, that doesn't look nice. Let's get this down here. So that's going to be x minus 2 times -2 plus 3 times z, which is 1, equals 9. So x plus 4 plus 3 equals 9. It's going to be x plus 7 equals 9. So our x is equal to 2. Okay, it's a great idea to write these answers as what we call ordered triples. In other words, in alphabetical order. So x is 2 comes first, y is -2 comes second, and z equals 1 comes last.